that's research is more about kind of like the idea of human interaction, kind of computing. And so again, we're talking about different kinds of scales. And so I'd be curious to see if one of you, Jennifer or Beth, maybe talk a little bit about kind of your reflections of what you just see from Michelle and Sheila's presentations.
I'll give it a try. So I'm recovering from some allergy-infested lung thing. So when I start coughing, Jennifer promises to take over. So Julie, thank you. It's a real honor and exciting to be part of this symposium. I come from the computer science world with a little mix of engineering psychology. But from that computer science world, I never get to be on a panel with all women. So I'm already texting my daughter, this is what you should go do. She's 13, so expect her in a few years. And I wanted to start with this tension around measurement and consequences. And for the past decade, I've worked in the field of health informatics, which I think is a minefield of unintended consequences around measurement and consequences. So just to give you a few examples, and I tend to work in the scale of the personal device up to the home. So I'm gonna start with the mobile and work my way up because I can't resist the smart home commentary. But I've worked in mobile technologies for diabetes management, and so you want to control blood sugar, right? And I'm sure statistically speaking, there are people who are diabetic in this room. So we've developed mobile technologies that help people gain a better understanding of their blood sugar and its relationship to their practices. And the intent, of course, is to improve their health outcomes, and overall enhance their life. But what we did, and this is common in my field, is we focused on the measurable part of that. So we focused them solely, we got them to, the technology focused them on those numbers, right? And so what did they do? They became really good at controlling those numbers and keeping them into a reasonable value. Did they do that through improved diet and health and activity? No, they did that by abusing their insulin dosages so that their numbers were always where they should be. And so they just essentially pushed downstream a problem in terms of not actually going after the intended consequences of this environment that we're trying to create. So my environment is usually the technology and the human behavior part of it. But by focusing on what was measurable, we essentially created an unintended consequence of something that might actually be a worse problem. And we do this frequently. So there are a gazillion lose weight apps that are out there. Probably all of them are crap. But what they do is they focus people on the wrong behaviors, right? And so they will gleefully let you set unattainable goals. All right, I'm going to lose 20 pounds in a month before my friend's wedding, right? And they will gleefully let you set that, and then when you don't achieve that, then you give up on the goals or what you were trying to achieve. So I just feel like in my world we had this desire through the lens of technology to focus on something that is quantitative, to try to steer human behavior in ways that are either harmful or ridiculous. So the ridiculous is I can't resist the smart houses. I love the video clips. The video clip that maybe some folks have seen in the audience is the magic smart doors on Star Trek, right? So Captain Kirk is, walking dramatically and is going up to the doors and they make that noise, right, as they open and close. All right, so how many people think that was a real door that was automated? Okay, I said it that way so no one's gonna even think. But it's of course two stagehands who have ropes that pull these things. And there's these great outtakes that you can see of Captain Kirk walking, and he was supposed to turn and give a speech and he doesn't, but the guys don't open the thing fast enough and walk straight in it. Or these times where he turns and dramatically gives a speech, and if it was a technology system, it would be like the grocery store doors. They'd be like, but they're waiting for that dramatic time to do the right thing. So we have these expectations of how these systems work, but it never plays out in those ways. So in my world, we have this concept of seamful design, and I don't know if that is also a term of use in architecture. But what we do is we're referring to the seams that technology creates and how people start to think of the seams in the technology just as much as the physical affordances within the environment. So some great examples of this can be Wi-Fi. So people have actually designed games where you essentially can hide in the Wi-Fi shadows. And you're essentially, it's like a scavenger hunt or a game of tag, and people learn where the seams are. In smart homes, there's again beautiful video clips of one of the first smart homes that was built in Colorado where it had those great sensors, right? You know, the classic, you walk in and it turns all the lights on and does everything for you. And so there's this guy who, it's his house, he's designed it, and he's literally sneaking in the night along the edge of the walls, you know, around the edge, trying to sneak into his house because he doesn't want the lights to turn on, right? So he has figured out the seams of the sensors. And he knows that if he steps right into the room, all the lights will come on and it'll disturb his wife, and that doesn't want to happen. So he has now created his own house where he has to skulk around to try to not get it to automate the way it was designed to automate. It's absolutely crazy, these tensions that we put up. So I want to end with a positive story, and then I'll turn this over to Jennifer. But I think the situations where it has worked has been a concept of under-design and adaptation. And how do we actually design technologies with an overarching soft goal? So in this particular scenario, it's going to be an overarching soft goal on human connection, and then we get these positive intended consequences because we allow people to adapt and shape the technology towards their overall goals. So we had another smart house project, but in this case it was a project on caregiver awareness. So the scenario is elderly mother living by herself, and maybe a spouse has passed away, and their adult child is worried about her living by herself, you know, hours or time zones apart from each other. And how could you provide peace of mind awareness between these two groups? So we spent a lot of time under designing a system that would provide just a modicum of information between these two stakeholders. So in this case, it was the older woman living by herself and her adult son. And we did not use cameras, despite all the technology people raising their hands really high and saying, but you could have cameras and you could have a picture of her, and if she's having a bad day, the picture could change and she could turn gray and look scary. And I'm like, why would you do that to a family? We didn't use cameras, we used very simple motion sensors. And we put motion sensors where it was okay with her, and you just got a very modest sense of her movement throughout the house. And the adult son had a visualization of her motion throughout the house, abstracted. It was actually pictures of butterflies. That's a long story, but it was an abstract notion of her motion. And she didn't have anything, which is important to the story. And so we have a lot of interesting stories where the son got really clever in how he could adapt what he wanted to know or needed to know in the context of their relationship. So if he was worried about her coming home late, he could just watch the system, and then when it flickered on to show that there was some activity in the home, he knew she was there safe. He'd wait 10 minutes, let her get settled, and then give her a call to see how her day went. Because he hated like constantly calling or constantly hitting her right when she's coming in the door and having to rush to answer the phone. There was another story where the sensors were going haywire. It looked like she was just going, they were just going way too high in the house. So he was a smart Southern son, I will say this, and he called her up and he didn't say, hey mom, that thing that I have that watches you, well it tells me you're up to something, so what's going on? At which point she would have unplugged the system. But he just called her and said, how are you doing? And she said, oh, I'm having a great day. I'm finally getting around to painting this hallway that I've been wanting to do. And so she said, I've got the primer up and I'll be able to finish the painting tomorrow. Well, she had been pegging between two sensors all day long, and it made the numbers go high. So long story short, we interviewed her towards the end of the study, and I felt really worried about how that interview was going to go, because she was 80-some odd years old, and the longer the study went on, it was like the healthier she got. right? This was a very independent woman, didn't really need our help, in my opinion, and maybe really resented having this kind of technology in her home. And so we interviewed her, and it's like, okay, here was this day, and it showed there was a lot of activity, and you were in and out of the house. She's like, oh yeah, I was guarding, and the interview was proceeding along. And, we said, kind of at the end, how would you describe this system to maybe a friend of yours? Because that's a kind of classic interviewing question in my field, right? Just how would you describe it to someone else? And she said, I really, really, enjoying the system. She said, it made me feel less lonely. And we sat there and thought, that makes no sense, right? Because she had nothing in the house. She didn't have a picture, or there was no manifestation of the system in her home. Maybe, made her son feel more connected because he had a thing to point to. But, so we were like, okay, it made you feel less lonely. How? And she said, well, there's days that go by where I don't even speak to another human being. I'm at home doing my thing. And I just knew it was there, that I had a connection to Rob, her son, that I didn't have before. And because of that connection, I didn't feel as alone. I felt less lonely. And if we had started that project with, we're going to measure loneliness, and we're going to design a system to make this woman feel less lonely, I can list off the 20 stupid things we would have tried to do. But we started a project with a modest desire of creating a very small connection between these two family members, and then watched it play out as they adapted and shaped it around their social relationships and how they interpreted those relationships in the context of something much larger. So it is nice to see, and I wouldn't even have a pretty picture if I was trying to show this to you. As I said, I don't work in the built environment, but I work in how the built environment is reflected in these relationships. That when we under-design and we let kind of these larger goals of what human beings want to achieve with each other, then we can actually do some things that are, if not profound, at least really interesting. So I will stop there. I have other fun stories, but I'm not coughing yet, so I'm doing good.
Oh, that's great. Great. Julie, thank you. This has been really, really lovely, and I really appreciate that you're starting the conversation on the discussion and on this piece about scale. I think that's a very important component of this. And it reminds me of, I was at a Buell Center symposium at Columbia longer ago than I care to remember, and one of the things there was a set of presentations, much like today, and many of them were on high architecture, sort of some Mies, we've got a little Mies, we've got a little Corbu in there, and then there was one presentation that was on Southern schoolhouses and segregated Southern schoolhouses, and it just stood out. It just completely stood out as being a completely different. It wasn't about the technology. It was about sort of the program, in addition to a lot of other sort of socioeconomic, sociocultural issues around it. And Gwen Wright was the discussant on this panel, and she said, we have to get good at thinking about, and I hope I remember this properly, and don't misattribute this to her, but really that we need to get better at understanding the different sites of inquiry, and that we continue to have rigorous methods and approaches to how we research these things, but that we need to get better at thinking about there being a much more diversity in terms of the sites of inquiry. And I think this question of multi-scalarness ties in with that, and also this question of measurement, because clearly the metrics are different for measuring in the different sites of inquiry. And when we think about whether it's the scale of the body or the individual in a health context, or the scale of the building, or the scale of the neighborhood, or the scale of the city, we're going to be looking at very different units of analysis in order to understand, and different metrics for that reason. And if we're not clear about that, what ends up happening is we end up sort of misunderstanding you said it very nicely at the beginning of it, really what the results are from the measurements that we get. So one of the things because I work on technology diffusion, I was hearing things about technology diffusion in all three of the talks, and in Beth's comments as well. And one of the things I think this always highlights is this issue of we sort of, and particularly when we're talking about technology, we think that if we measure things correctly and somehow convey the results sufficiently, that then we'll actually be able to, and that those results show demonstrably that the thing we're looking at is better, right? That then adoption is assured, that the predecessor technology will be superseded by the betterness of what we are proposing. And that is, it can be greener, sometimes it's greener technology, sometimes it's actually just simply lighter. I mean, there's all sorts of different words we can use for how it could be a process, it can be a material, it can be a product, but we get very confused when this is insufficient for making the change, right? And you even hear this often when people say, and I'll say this from the faculty member's perspective, we often now get advice from media and communications people who say to us, don't just publish your results in the papers, tweet out your results. Or they'll say to the scientists, and I feel terrible for my colleagues who are scientists, they'll say, oh, scientists don't speak well to reporters. Go take a class on learning how to talk to reporters. And that somehow, if we could just get this word out, that this would in fact happen differently. And of course, that's just not the case. The path dependencies are not just about us not explaining how the technologies are better. The path dependencies are entrenched patterns of behavior. It's not the issue that we have just better technologies, and if they're better technologies, they substitute for the incumbent technology. It's that they have to be substantially better, not similar, because they have to overcome the path dependencies that we're looking at. So what does substantially better actually mean? Well, we first, and I bring this up particularly because I'm looking at a lot of amazing technology that was presented right now, and I spend a lot of time with Beth, who has nothing but amazing technologies to diffuse out into the world. And I thought the comment about test beds was a really helpful discussion too, because we think a lot about the test beds these days as ways of moving forward more technology diffusion. And I think one of the things we need to think about really is this question of institutions and intermediaries that function to push forward technology diffusion. And that is where the policy professor in me sort of stands up and says, you know, we need to think about this not as a government issue per se, but this is about all sorts of institutions, all sorts of firms, all sorts of individuals, all sorts of institutions actually learning how to absorb change by understanding the opportunity, adopting the technical difference, so that means actually getting better at understanding the technical difference, and then accepting the risks of uncertainty. And that has, that's really this issue of understanding the potential for new and different transaction costs. And I was struck by the Brazil case as an example of the incredible ability to embrace that risk and that uncertainty when you don't know what the transaction costs are going to be, but you take it on anyway, because the opportunity is just too good. And then the comment about value engineering, which is always one of my favorite phrases in the world, is value engineering, because I now know what it means, is the idea too that we're not just talking about packages of technologies that are displacing other technologies one for one. We're talking about the problem of, once you have a package of better technologies to implement, if you have to value engineer it, it's also about how the stripping back of the core versus peripheral functions are how do they perform? How does it perform when it's 75% of what you intended, which is more likely, right, than the 100% of what you intended? Is it going to perform as well as the 75% of the incumbent technology? So these are things that then move us to the question of test beds. And I really go back and forth on test beds, and we can talk about that a little bit. But one of the interesting things about the test beds idea is this idea that if we can prototype these at full scale, these technologies at full scale, that these will be convincing, that people will then have the lived experiences of these new technologies in real time or real space or real place, right? So instead of just the metrics, just the measuring and saying, see, this is 25% better, you actually have people live in your 25% better experience, right? And this is this idea that we see this a lot now in urban infrastructure projects, shrinking down the scale of the urban infrastructure projects to the point where you can actually implement a smaller scale and then develop a constituency because you have the public experiencing it. And the example that I tend to use in this is that the Cheonghaechung in Seoul is a very good example of a scaled down linear park urban intervention that could have been a lot bigger and is actually intended to be a lot bigger, but the effort there is to build a constituency around eventual implementation of something like that at a much broader scale. But the constituency that gets built then actually advocates for it, understands it, and pushes that technology diffusion forward. The challenge, though, and I think we all sort of touched on it too, is that when you do test beds, when you do incremental implementation, you also open the door for uneven implementation. And that leads to potentially questions about distributional equity and uneven development. So you can't just test bed it in one place and one time. You have to actually have somewhere on the back end the commitment to broad access and expanding broad opportunities. Those are the comments.
I think that it's interesting since I've heard a couple of things that both of you all said. We talked about, obviously we're talking about scale. How do we design technology with an overarching kind of soft goal? I love when you talk about the seams that technology creates. I haven't actually heard that term talked that way myself, and I think it's so interesting that you can begin to imagine that seam being, again, at the scale of, between, as a joint, as in kind of in detail. But then as you were talking, Jennifer, I found myself thinking like, wow, it's also at the seam of city fabrics, too, between cities and suburbs or between neighborhood districts, and how do we start to, and then I was reminded of one of Hannah's slides where she started at the kind of very small scale and ended up at the kind of building envelope, but really kind of asking the same question and then testing it at the different kind of scales and understanding it. And basically maybe reiterate the fact that the solution is different, or the findings are different based on the scale, and then you recalibrate the kind of lens with which you're evaluating the test bed or the test case based on what that scale is. So I'm curious, I do want to open it up to the audience. I'm curious for Michelle and Anna and Sheila maybe to respond a little bit to what Jennifer and then Beth put out there as part of the initial part of the conversation.
Well, I mean, you're obviously both experts in your field, so it's a little bit intimidating to.
Likewise.
I mean, it's just a simple question rather than feedback. But I guess my question would be, that perhaps it's a modern artifact that technology is always better. And I think that we can also make a useful distinction between incremental innovation and so-called disruptive innovation. If you want to refer back to Leighton Christensen's book, The Innovator's Dilemma. But anyway, sometimes new technologies actually underperform. So they're not 15% better, they're 85% worse. And I think that I'll just make a comment. I think that the creative challenge might be not only to make them better, which might be what would happen in the engineering process, but to find the particular niche or test bed where they could have value. And for example, LEDs is an example of that. The holy grail for LEDs was architectural lighting. We still don't really have architectural lighting. Only made here in this building, but I think those are non-LEDs. But at any rate, the cost of getting the light from an LED down to where typically conventionally the work surface is would be far too great, and the LEDs were not bright enough. So they started out in traffic lights, where even before you had white light, you could have green light and red light and amber light. they migrated to the tail lights of cars on automotive platforms, and now they're migrating to forward headlights. And so I think that in order for a country to invest in new technology, there need to be these kinds of milestones and incremental improvements. So I think there is a huge opportunity for a variety of different disciplines, including architecture, to identify creatively what those niche markets might be, and find a way to sort of test and use that technology before it's quote-unquote effective.
I'd say there's no question that, I'm absolutely enchanted by technology and new technology. I mean, I wouldn't have had the career I had if I were not. However, I'm more interested not in the technologies themselves, but in their instrumentalization. So I don't think so much about the diffusion of technology. I don't think about the deployment of technologies. I think about it in terms of, what ends am I there to achieve? And I think that was part of my trajectory when I realized that I was not going to achieve the ends that I wanted to achieve with the analysis that I was doing, the technology that I was working with, is why I stepped back. And I had this course that I used to teach, as I mentioned, on smart materials, and it went through a variety of different iterations before it's gone. And instead, I teach the same content with dumb materials. And the idea is that if you absolutely understand what it is you're trying to do, if you understand how things work, and you're able to sort of like causally, through causation, relate how things work to what those end results are going to be, you can do it with anything. Any combination of materials, any archaic technologies, you can make it happen, but you have to know how things work and what your desired ends are. And I mean, as an example, the first assignment I give in a class I do on discrete light, our students have to build a dynamic behaving system, and nothing can move and nothing can change. Yet the behavior has to be dynamic. And it's actually surprisingly easy once you sort of begin constructing that relationship. So I do think that's a part of this that we can't lose sight of, is that issue of instrumentalization. That my hope through that is the advanced technologies come in to be very strategic ways to make those things happen, but they can happen in almost any way that you could imagine. So that's part of how we move forward, is first of all sort of like making the behaviors happen. Then when the technologies come into play, they're not about a radical shift in the behavior. They're about finding a way to streamline it, to make it more seamless, to make it more inexpensive. In the end, to make it more inexpensive as opposed to expensive.
And I think it's one of the issues that I want to highlight, which I think parallels what you're saying, and I'd love to hear more commentary from this panel on this, is the Internet of Thingsness. And it reminds me, as soon as you said smart materials and dumb materials, it's in many ways the same idea. And the economic costs are being borne out differently, but I think are being wholly underestimated in the Internet of Things approach. So how many people have a Nest thermostat? How many people essentially have, some form of cloud-based appliance to do something smart within their home. In contrast to what would have been the previous kind of Radio Shack Tandy version of the same smartness, which would have been a standalone system. It would have been more complex at the beginning and maybe a bit more expensive, but it wouldn't come with all. What doesn't come with that are all of the security and privacy concerns, much less kind of the downstream maintenance concerns of the Internet of Things approach. So in today's market, what you can do is put out an app that's going to have bugs in it, but that's okay because you can download upgrades to it later, and the smarts can be in the cloud, and you can have a relatively simple appliance within the home environment. But you're now creating opportunities where even the cloud-based light bulbs are a security risk for your home and your home network. And not to mention privacy and monetizing your data in ways that would not occur if you had focused on kind of the upstream complexity and cost of standalone systems. But most of those companies don't even exist today, right? And so, there's a question of, even if we, start looking at your pathways here, right? We've shut out most of the Motorola, Radio Shack, Tandy pathways in terms of those types of systems, at least in the consumer space. But we're opening up and now leveraging these cloud-based pathways, not paying attention at all to the downstream costs, both real in terms of maintenance and threats in terms of security and privacy.
I think that it's absolutely fascinating to hear you speak about that. And I think maybe analogous to your question about investment and autonomy, right, standalone or in cloud, is a fundamental question about the degree to which something is centralized or decentralized. And we certainly have all signs point to kind of increasing centralization of capital, of data, of toasters that will speak to refrigerators or whatever the promise of the internet and things is. But at the same time, I think we have seen like the inverted side of that with platforms like Etsy or Noco or 1,000 Garages or things like that are both decentralized and centralized at the same time. So I think that the new models will be surprisingly diverse in terms of being both standalone and also referring back to some kind of central matrix.
Yeah, I agree. I think there are tremendous sort of hidden risks to this multifunctionality of trying to basically make less things do more, and I think it's a huge danger. I mean, but on the flip side to that, I do think that the more that we're able to get sensing and control networks that are truly sort of decentralized without it. Right now we're sort of stuck in this paradigm where there's always this relationship between greater and greater decentralized networks and then the top-down controls, right? So there's this relationship that we have now, but I think as we get more and more biological paradigms and truly biotech paradigms, the degree and potential for decentralization will be far greater. Now, that poses all sorts of other risks, of course, which are, probably beyond this discussion here. But I think that issue of control of information, of access to information, of the dispersion of information is something that is, beyond control at this point. I mean, it's out there. So the question is, how do we manage it? And how do we respond to it? But I just wanted to go back also to that issue of unintended consequences, because I was very moved by this story of the elderly lady, and I think that this kind of thing has happened throughout history, obviously on a very large and small scale. Just a small example from ours is that, a lot of the biotech stuff that we're working with in plant species was intended by, to colonize space through NASA with closed-loop ecologies and all of these kinds of massive programs that would have never been funded if we were for the purpose of buildings, because we would have never thought of that. Like, why would we possibly, why would we even think to do something so sort of absurd, even in this day and age, possibly? But the point being that the unintended sort of spin-offs of technology, the LED is another good example. We have so many technologies that if there were greater possibilities for translation across, a lot less information would be lost in the process. And so, I think I was just, thinking about that with your thermoelectrics example, Michelle, at the beginning. I mean, very soon, so many of the wearables and the cars and automotive and whatever are incorporating, some aspect of thermoelectric because of that, very tight bounding layer of thermal comfort that they're able to execute. But that's such a circuitous route, really, from the original sort of intentions of those studies. And so I think that, we can, I don't know whether or not there's just a glut and we're not actually getting more of these sort of tight circles, or if you know, the amount of information and the amount of connection, information-wise, will facilitate that. But it's just, I think it is worth thinking that, in general, I do think that more information and more intense information is entering the system. So this discovery, in a way, you know, that you pointed out, I'm wondering if it would have been, you know, I wonder if that discovery is very, very much a function of the fact that you were able to execute that technology at that time, to many means, opposed to having done something else. So you see the social because of more information.
Because of this, because it was available within the system. And I think, you know, part of this, and I was moved by this notion of the lighting and the health, and the lack of circadian rhythms reminded me of, I think that's actually how Vegas is designed, right? So you have no sense of time when you're there. And so this overall sense of the relationship between health and policy and technology coming together. And one of the areas that I've worked in recently is around kind of prosthetics and wearables, but we've also have focused on wheelchair and robot technology, because in the appropriate world of diffusion and invention coming together, these things should be reinforcing each other. But if you look at the marketplace, what you see is that most wheelchairs that older adults have available to them are quite poor, decades poor, compared to, you know, autonomous vehicles. And how could these systems, how can we have hybrid electric systems that can, you know, drive around for a city day at car scale, but we can't accommodate some of those same capabilities in wheelchairs. And it's all about the policy surrounding the expectations of those technologies. So if you're under Medicare, which would be the bulk of the buying power, wheelchair technology is under the policy of health in your home. So it is surrounded by the walls of your home, and if you can circumnavigate your home in a wheelchair, so that's essentially bedroom, bath, kitchen, very modest distances, then that is sufficient for the policy expectations of wheelchairs. If you're in the veterans system, the veterans policy expectations is not pure survival in your home, but it's about engagement. It's about keeping up a job. It's about getting out into the community. It's about social engagement. So the policy driving the technology innovation around those systems is, you know, not bedroom to kitchen, but it's going out for a full day, either through employment or engagement. Completely different systems available at price points that make no sense except for the market optimizing around these policy decisions. And so if we're not paying attention to the policy component of what we expect to come out of these technology, health, space, environment combinations, then the market essentially creates this lowest common denominator within that space. And so the report that I was on has made recommendations to try to change this. So maybe we, you know, if you shift the policy, then the market will change. But if you just looked at autonomous vehicles and robots and everything that's out there, and then you look at the commonplace wheelchair, it makes no sense unless you also look at the policy component.
I think to your point about diffusion in the built environment, policy is going to be king for so much of this stuff.
Exactly.
Otherwise we wouldn't see it, especially related to energy or environment. It really has to, in a sense. That is one top-down moment, what will we have to see?
Well, and there's just to build off of what you've said, Beth does a great job of actually going and doing policy engagement as a technical expert in her field, and many of us don't do that because it's hard to see the direct line of why that is so critical and relevant. But these barriers to entry for new technologies, but also new firms, often come from certification, because of policy certification. So every time there is a new technological innovation, and taking very seriously the comment that not all technology is an improvement, I underscore that, yes. But those new technologies or materials or processes, many of them, particularly if they're going to have any sort of public sector funding behind them, have to go into a certification process, right? So we need to go up to NIST and say, this is part of what we need to be talking about, and this is particularly true with the built environment. And weigh in on those conversations rather than allowing others, people who don't actually understand the context of the deployment of the technology, but simply just understand the technology full stop. That's where most of the certification comes to. And if you're not certified, whether it's in the health environment or whether it's in if you think ADA, you think about all the things that affect the built environment, then you will not actually have a product in the marketplace. It just will not happen.
I'd like to, before we run out of time, this conversation is so interesting. I love how we're covering all of a whole range of topics, from hearing through the lens of all five of you. But I'd like to open it up to the audience to see. I'm sure there are some questions out there that you all have for any one of our five guests.
I was just kind of wondering, you guys all work on different projects with the library materials, and I was wondering if you kind of get into a group and working through the same process with different materials and different outcomes, or if you approach every project with a clean slate and start all over.
We all step back, there you go.
It's an interesting question. It's a broad question. Just maybe one specific instance. For example, how did we, and this would be perhaps a funny story, but how did we settle on phase changing material for the linen? Originally, the manufacturers were thinking in their innocence that perhaps there could be something electrified that could happen, like luminous linen or something like that. Part of our process was completely subjective, and part was quite empirical. Just subjectively, we said, you have an amazing natural material here. You don't want to get into the whole problem of connectors and electrification and batteries and power storage. Just let's steer clear of that. And then we looked at what the material has in affinity, what its properties are. And we tried to take a really thorough account of all the material's properties, including ones that you might think are the most trivial. So perhaps if you were designing something with fabric, you might think about yield tests, you might think about strength, you might think about those things. But it turned out that the most unusual thing about linen is its ability to absorb. It's baked into the molecular structure, actually, of the flax plant, and the way that it's processed. So that opened the door to potentially joining the linen with something that was wet, at first at least. And so within the manufacturing consortium that we set up for that project, it had to be all French, by the way. That was a mandate. We were able to find a manufacturer who had developed a very early, stage paint that would enable a building to be coated on the interior of its paint. It would absorb heat, and it would re-release that heat at the diffusion point of the phase changing material. And so we were able to manipulate that material, working with that company and working with the manufacturers to tune it to our needs. And also, we had to have a material, we really wanted a material that was 100% natural. For kind of an intellectual idea of making a supernatural material. One natural material plus another natural material come together makes a material that is completely natural yet not found in nature. That was kind of an idea of interest, concern, interest. And so that's just one description of the process.
I've asked the same question every day of my life since I was 13. And it's when I found maps of nuclear fallout. And, I certainly had imagined until I was 13 that nuclear fallout was evenly dispersed or was in a ring type of pattern, but instead it shows up in sort of very narrow cigar-shaped patterns that are perpendicular to the jet stream. And I was fascinated by that. And so ever since then, it's a question that drives everything I do and every material I look at. Is I just want to know precisely how energy is exchanged. I want to know the moment that it's exchanged. I want to know sort of like, to sort of like draw my tiny boundary around that exchange. And it doesn't matter if it's exchanging forms or exchanging a place. That's the same question, and it permeates absolutely everything that I look at.
That's inspiring. That's inspiring. Very inspiring. You know, I don't work alone, so we work in sort of large groups, and a lot of what drives our process is research-based and sort of driven by areas of inquiry and questions. And so projects sort of stream in and out of that. So instead of something being sort of project-driven, the projects are kind of maybe more like test beds, maybe as you described it, or opportunities that we have to maybe test a hypothesis or test something that we're doing, experiment with something that we're doing and get some feedback. So I wouldn't say it's a blank slate, and we always kind of joke, you know, at our center that everything's a mental, whether or not it's a new project or a new building or whatever, everything's a mental retrofit, because it's always sort of all of these sort of cognitive structures that we have individually and collectively, we're always sort of falling back into some of these vestiges or these traps. So I would never think that we're going with a blank slate. However, I wish we could, but we try our hardest, let's say. What we really try to do is really question our assumptions and really try and, in a sense, put things in a sense in competition with each other, if you will. So when it comes to materials, we always try to say, well, we're system agnostic, we're material agnostic, whatever. We try to bring it down, once again, to some of the essential questions that we're asking. And that helps a little bit to provide resistance within our center and with respect to what others are doing in the world, et cetera. So a lot of the research we're doing, our students are doing literature reviews, and they're sort of seeing what's happening out in the world. How have other people asked similar questions, or how have they responded to similar questions, and then how would they situate their arguments relative to those people, so or those fields, if they're disciplines or if they're groups. But I think you raised such a wonderful point, which is that can we try to create that tabula rasa where we divest ourselves as much as possible from assumptions, and I think it does go back to this issue of the unseen. And one of the ways in which we do this, and I hate to be, I'm going to sound so technophilic today, which I really am not, where like I kind of totally agree with all this sort of fatigue with the technology, et cetera, but I do think that these sort of massive amounts of data that are interchanged in our exposure to feedback loops that we did not set in place, that others set in place, et cetera, multiple models of, you know, presumably the same thing. I think we have more access to those kinds of resistances that force us to question our assumptions and force us, in a sense, to, you know, maybe divest a little bit of vestiges. I'm hopeful of that, although I do think there are also a lot of self-reinforcing mechanisms within the technologies we use and the models we use through computational frameworks and other things too. So it goes both ways. Maybe we could say nothing's changed. We just, you know, we're sort of stumbling around as much as we ever have been. But it's, you know, I think trying to create that fresh start, if you will, within groups or individually is something that we should all sort of aspire to and employ.
We've already been able to replicate the qualities of light up naturally to grow plants, for radiation, ultraviolet qualities. How far do you think we are from being able to replicate a level of comfort for the user if you won't be able to know the difference with artificial and what's natural?
What is the question?
It's how close are we to being able to replicate desired spectral effects of daylighting, let's say, because, you know, once again, daylighting is not always good, right? There's a reason we don't stand outside and do our work, you know, and so, and you can even have too much ultraviolet light or daylight, you know, inside. So having said that, but yeah.
I think we're very close. I mean, I don't think close in terms of time. I actually think we're completely capable now. There's actually some wonderful work that's been going on in Joe Paradiso's lab, media lab at MIT, and that's actually been quite some time of working with LED systems that can mirror the spectral distribution of what's going on outside. When I was consulting on, the British Art Center has a variety of problems. Another problem they have is that in order to keep true to Lou Kahn's legacy and the lighting designer, they have never changed the lighting system. So they still have lighting technology. They bought up the company when it went out of business, and so all the lighting technology was purchased in the 1970s, and they're running out. And so I proposed for them actually a daylight mirroring system that we could easily build and we could easily control within that, and they're petrified of the idea. One of the reasons I mentioned what was happening in cinematography, digital cinematography, has developed a set of LED systems that have incredible control of lighting conditions. They develop them precisely so they have really good modeling of skin. And what they've created, we don't use anything like this in architecture, but those things exist out there. So it requires two things from us. The first one is that we really have to understand how these things map on the retina, because you can actually make all of that much simpler if you realize we're only dealing with 4 opponent systems, because you only have to work with the opponent systems within that. So that cuts out 75% of all the things you'd have to do in order to mimic daylight. But we don't do a good job of understanding or sort of translating what is hitting the retina to the things that we're making. The technology's there, the analytical tools are there, but it's neurobiologists working with visual psychologists, working with electrical engineers, working with designers. It's a group of people that don't normally work together. And I think that's part of the dilemma of that. So we're there in terms of the knowledge, we're just not there in terms of bringing it all together.
Another thing just about the spaces that we create, where we have to have multiple users. One of our PhD students, his dissertation is actually, he's working with Mount Sinai Hospital, and I'd love to have you guys come down, because he's trying to design a condition where if you think about the operating theater and you think about a very at-risk patient and the spectrum of light that they need to have versus the person operating, right? The person operating wants the blue spectrum. The patient does not. The patient wants to be at as much a restful state as possible. So how do you start to create, in the future, first of all, as we said, we're not recreating the outside, inside, quote unquote. It's not, there's a reason we do have buildings, we're creating, we can be in control of what we select and what we deselect relative to the spectrum. And per the British Art Center, I was wondering, Michelle, about this issue of the blue light and that sort of vestigial attachment to blue light, if it actually might be more about the painters or the tradition of studios and ateliers showing their works, because of course the blue light is the best light, quote unquote, to paint from, where that's been the received wisdom for centuries. And I was thinking about that when you were presenting, because the doctors, they're doing all these sort of cognitive tests on executive function with the surgeons, and it's that blue spectrum that they're liking the best in terms of alertness.
That's the part that sets the hormone system.
Yeah, exactly. And their ability to concentrate, and then even their ability to, so there's the hormonal issue, but then there's also their what they can see, how exactly they need to see, the degree of precision. Most of us don't need the precision of the Renaissance painters or of a surgeon, a neurosurgeon, etc. So we might not have that predilection or that preference for a type of light, but understanding, the kinds of light that we really want, we're just at the beginning, I think, of that study as a culture.
Going back to the very beginning of the afternoon, we're rolling back forward. This idea of, you see what you see is not necessarily what you know, and then led to insight of some sort. In this
the unseen, and then what standard to measure the unseen to, and what that system to measure might be. And my question is, how do you come to some sort of consensus, and especially when different groups, different professional groups, in the kind of collaborative situation that we're talking about? And is there a value to prototyping or internal prototyping to gain that sort of, in other words, establishing a new standard measure that could be more consensual in that sense?
I think it's a terrific question on the technology design. Everything from scenario storyboarding to prototyping to kind of conceptual mock-ups, because oftentimes in these interdisciplinary collaborations where I've got healthcare and I've got designers and I've got engineers all coming together, is that I have to work with the team to create a new conceptual goal that neither group could articulate by themselves. And to some extent, the artifact necessary is what convinces the team to move in that direction. So for some teams, it might be just sufficient to have a storyboard or a scenario. For others, it's that, okay, this is what prototypical data could look like. Can we move in this direction? Many of the things that we've done in the smart home environment, the conversations with the engineer, computational perception is their world, have boiled down to, well, we can sense anything, but we have no idea what matters, right?
Exactly.
And we can sense things all day long, and if you've got enough data, you can always find something, right? But that in no way is steering the ship towards a goal that's actually going to solve a problem or meet a need. So, we spend a lot of time in those intermediary artifacts to again try to move that conversation, but it's because we're with groups that are starting from such different vantage points that if you don't create that common ground and figure out a roadmap to get you there, they will continue working towards their traditional goals, and you will never have a system that comes together. I don't know if buildings work the same way, but
I think it's the question that determines that. It's not what you measure so much as the clarity of the question that you deal with. One of the things that I find gives creates a stable communicated ground within the sciences is if you can keep your question in relationship to orders of magnitude. You're not measuring anything, you're just sort of looking for governing phenomena. And if you can name that governing phenomena, there is now a common and a stable field from which to discuss. But I do think sometimes in the field of architecture, we do hope that data will give us an answer that'll somehow emerge from, if we collect enough, if we simulate enough, if we model enough, something is going to emerge from this. And it is sort of understanding that the data should be the test of the hypothesis, but it's not going to reveal the hypothesis. So the hypothesis actually can be a great gathering point for people from many, many different areas.
I think that's a great way to end the conversation, because that does sum it all up, and really, I want to thank all 5 of you for participating in the symposium, and it was such an incredible discussion. Well, first started by 3 very incredible presentations, that then led to an incredible discussion from 5 leaders in each of your fields. And we're having this conversation, we're talking about technology, we're talking about relevance, we're talking about scale, we're talking about all these issues that I think that we as architects can put ourselves in our own kind of sandbox. We talk about that, but what I appreciated so much about this conversation today is we were talking about this, but all of a sudden it's so much more interesting for me when we're looking outwards. And that it's not just about self-referencing ourselves in our own conversation, but engaging in this kind of very rich and complex discussion, which in the end, there are no questions that are answered necessarily, but I'm so inspired by what I saw from Michelle and Sheila and Anna, and then the contributions with Jennifer and Beth. I mean, it's really incredible. So I want to thank you all very much for joining us. before we do a round of applause, I do want to invite everyone to architecture on the main floor. We have a reception. Please go. We have food. That way, and then you might have an opportunity to talk with our 5 panelists. They're in a more informal setting. So thank you very much.